lesson 4 is about puzzles and games. And if you didn't get your quiz done, you can hand it in later. But I just want to go through lesson 4 here. We're not going to do all of them. I will save you that. But this one I'm going to for sure show you. What page are we on, guys? 87. So this guy here, he's doing a pathway problem. You can call that a pathway problem. Okay, I'm going to put a star beside it for obvious reasons. Yeah, it'll probably show up. Now, when this ball is dropped from the top, you guys ever seen Plinko on like Price is Right? And the ball just drops randomly and falls in the bottom? So there's some probability that you might land an A, B, C, D, E, F, or G. Do you agree? Just by being clever, which one do you think it'll land in the most? Do you think it has a better chance being in the middle or on the edges? I would think that it would probably be near the middle. Correct. You do not know where it will end up. But there is a likelihood that it will end up somewhere more often. Right. So what's going to happen is this ball's going to hit right here, and it's going to go left or right, but you don't know. So what we can do is we can put a little 1 right here, which indicates that there's only one possible way to hit that top part of the triangle. Do you agree with that? There's only one way to get there, right? No, there's only one way. It drops in. It drops in. There's literally only one way to hit that. Now, this spot right here with my pointer, this spot here, how many ways to get there? If you went this way and then hit there, that's one way, right? Or you could go this way and there. So how many different paths are there? 2. So we'll put a 2 there. With my pointer, how many ways to get here? There's only one way, right? Boom, boom, and that's it, right? You can't go like, ugh. Right? You can't jump across like that. Yeah, so do you agree that there's only one way to get to those edges? Let's not try to do what if scenarios. Let's just try to stick to the reality. So, what about this dot? How many ways to get to this dot? There's only one path because you can't like backtrack. So, what do you think all the edges are? Good. So just put all the ones on the edges. I hear a lot of people talking about a triangle. Pascal's triangle? Right. So like, how did I get to 1 plus 1 is, so what's this guy right here? 3. And just to do it once, just so everyone can see it, let's just highlight the different paths. Just once. And I'll just make sure this is nice and small. Okay. So, is that a path? Forgive me while it takes me forever to change color. Okay. Is that a path? And then what's the other path? Like that? And that covers all 3? Good. And that pattern continues. So this one's also 3. Why is that 3, you guys? Because 2 plus 1 is, right? So can we fill out the next row? What's this one here? 4 and then 6 and then 4 and then, good. So 5, good. 10, good. 10, 5. Lovely. Now go back to that question I asked you at the beginning. Which spots do you think are most likely? The middle, because you'd have 20 different possible paths. And E would be 15, and F would be 6, and G would only be. So the edges are the least frequent. And then you have symmetry over here. Now, I'll draw you guys on the whiteboard a bar graph that would represent that. Actually, I'm just going to show you an animation. Just so everybody's clear, did we use inductive or deductive reasoning? Because we just played around. We just used, examples. Now we've done this on the bottom part of the graph. Okay. Could you guys reproduce this triangle on a test? All right. Let's give you a quick debrief. In the -2 curriculum, they have these puzzles and games. Sudoku and magic squares are the usual suspects. So, can you please skip ahead a couple of pages, because we're going to skip all that. I want you to do this one, but not right now. So for sure you're going to do number 1. Okay? And I just want you to skip ahead to page 93, number 5. Okay, so now in terms of importance, this one's important. Okay? The magic square. You could highlight this for me. The magic square, page 93. Guys, there's going to be some fancy rule that attributes meaning to these values in the box. It could be different for each situation. In this case, the squares of a 3x3 grid are going to be filled with the digits 1 to 9, so very similar to Sudoku, so that the sum, you have to add, each column, each row, each diagonal will add to 15. This one's very simple, because why? This is not a Sudoku, this is a magic square. Ladies and gentlemen, if each row, column, and diagonal have to add up to 15, what's the missing value at the bottom of that box? What is 7 plus 5? So you would need 3 more to get to 15. Now, did we just put a man on the moon? No. That was not hard. But I have experience, and I knew to look there. If you had no experience and you never saw this, you would have to do some logic. Well, I have 2 of the 3. I have enough information to fill that in, so logically I can keep going. Did I have to start there? Where could else I have started? Right here, right? 2 and 7 makes, so how much more to get to 15? Okay, finish it off. I want you to do those 2 squares for me. Yeah, so you always need 2 in the row, diagonal, or column to get the third. So I got 6 and 5 in the diagonal here, so I need 4 more. I got 4 and 3 in the bottom, that's 7, so just 8 more. 6 and 8 on the far side, so that makes 14, so just 1 more. And then in the middle row, 5 and 1 makes 6, so I need 9 more. And you notice that I've used all the digits of 1 to 9, and no matter what, when you add up a row, column, or diagonal, you get 15. But the second one, what's the problem? They don't give you as much information. So, the second box, I'm going to give you a little bit more time because it's harder. Alright, so it appears that there's 2 solutions for the second one. This is 15. So is that the correct? So this one with the star is the correct one. Hopefully, by what you've seen here, is that there's no one way of doing this, but there is clues. It's like if you play, you guys ever play the game Clue? Like the candlestick, Mr. Plum. You have to get the clues, right? And then you can go from there. Okay, let me teach you Sudoku quickly. Guys, listen up. Let me quickly teach you Sudoku. Please listen to me now. Guys, listen. 1 to 9 digits in each row and column, and each 3 by 3 grid. You see this grid? You see that grid? You have to have 1 to 9 in there. Okay? No repeats. Like if you had 3 and 3, that's bad. You cannot do that. So, let me give you a tip on how to do Sudokus, and I'll explain the logic behind it. Let's look at this row. Do you notice how you have all the information except one thing? Each row has to have 1 to 9, so what's it missing? A 4? No, it's missing 4. One with the arrow. Now check this out. Now that you've got 4 there, you only have 2 more spots to fill in that grid. So what's missing in that grid? A 3 and a 9. Here and here, right? Yeah, you see a 9 here? So that forces this spot to be 3 and this spot to be 9. Let's see if we can do some more of that logic. Let's take a look at this grid. Bottom right grid. Everyone with me? Bottom right grid. What are we missing from that grid? A 1, a 5, and a 6. Yeah, you can. But, oh my gosh, what just happened? What just happened? Oh. Where? Oh my gosh. Okay, I'll use my pointer. Let's look at this spot here. Could I put the 6 here? Why? 6 there. So this spot here has to be 1 or 5. Could I put the 1 there? There's a 1 here. So this forces this spot to be, okay, now I only have the 1 and the 6. Do I have enough information to determine whether this is 1 or 6? You would have to look up vertically. Is there any 1s and 6s here? No, so you don't know about those 2 yet. You have to move on.